Hey guys, so in 6.3, we're actually going to run a bunch of tests to figure out if a quadrilateral is a parallelogram. Okay, so we already learned a bunch of things about parallelograms in the last section. We're basically going to be continuing to work with those exact same things. We're going to add one extra one that we haven't worked with yet. But if any of these 5 things are true, then you know that your figure that you're working with is a parallelogram. So that's what we're going to be doing today, is setting things equal to each other. So in order to prove that our quadrilateral is a parallelogram, okay? So we already know this one, both opposite sides are parallel. We know opposite sides are congruent, opposite angles are congruent. We're skipping over the consecutive sides being supplementary, but it's still true. All right, we already know that the diagonals bisect each other. All right, they cut each other in half at the midpoint. So E in that diagram is the midpoint. This last one is that just one pair of opposite sides is both congruent and parallel. Okay, so if you don't have that both sides are congruent, or both sides are parallel, you could just prove that one side is. So for example, if you could show me that just A, B, and DC are both congruent and parallel to each other, then you could tell me automatically that that's got to be a parallelogram. Okay? So we can use any of those 5 tests to prove or to figure out a way to make these figures a parallelogram. Okay, so there's an example there for you to check out, and here's a few that I will take on. Okay, so in number 1 here, right, one way that we can show that these are congruent is by showing that both opposite sides are congruent. Right, so both of these would have to be congruent, which shows us 2 very easy equations. We could set up 2x minus 2 equals 12, which means that 2x equals 14 and x equals 7. Okay, you can also solve for y very quickly. 2y equals 8 and y equals 4. Alright, in numbers 2 and 3, for both of these, we're working with the angles. So we already know that the opposite angles are congruent, so we can make those marks. Alright, we know these are congruent as well. Alright, but we know as well that the consecutive angles are supplementary, so we actually know the third angle. We know the length of that. Okay, in order to find it, you add it up with 55, or subtract from 180, or subtract 55 from 180 in order to figure out what 5y is, and same way with the 25 to figure out what 5x is. Okay, so 180 minus 55 is 125, so I know that 5y has to equal 125, and 5x is going to equal 155, because 180 minus 25 is 55. Okay, so now I can set up my 2 equations here. So I know that 5y equals 25 and y equals 5. Not a good 5. Okay, and 5x equals 155. So x equals 31. Okay, number 2, similar type of problem. Okay, so we've got 11. X equals 55 because opposite angles are congruent. Divide by 11 to get x equals 5, and 5y has to equal 125. Divide by 5, y equals 20-something, 25. Perfect. Okay, and number 4. Right, in number 4, we're going to use that sneaky new idea that you could just prove that one set of opposite sides are both congruent and parallel. So if we show that these are congruent, that gets us y. That's real easy. 6y equals 18, y equals 3. Right? But if you also say that these are parallel to each other, right? If these two are parallel to each other, then this is a transversal that cuts it, and the alternate interior angles would also have to be congruent. Okay? So that gives me another equation I could set up. 9x equals 45. Divide by 9, and x equals 5. Okay, very similarly here at number 5, I could show that both sets of opposite sides are parallel, working with parallel lines again. So when you're working with angles, when you have transversals like that, tend to guess that you're probably going to have be proving that lines are parallel, and use the fact that you've got alternate interior angles. Okay, so if the top and the bottom are congruent, then that transversal makes these alternate interior angles. So x plus y equals 24. Can't do anything with that yet because I've got an x and a y in there. Okay, but knowing that the sides are congruent makes these alternate interior angles. So now I also have 2x equals 30. That is one I can easily solve. X equals 15. Now I can plug in 15 for x and solve for y. Y equals 9. Okay, and the very last problem. All right, once again, when you have two angles, consecutive angles that are equal to each other, you know that these are both right angles. They have to be right angles. It's the only way you could possibly do it. So I know that everything has to be a right angle. So 3x equals 90, and 6y equals 90. And I can solve both of those. 30, and y equals, what's that going to come out to? 45 over 3? That doesn't make any sense. 15. Okay, can't divide today. So, those are pretty easy type problems, right? Simple equations that you'd set up. You just have to understand their parallel lines and their congruent opposite sides, okay? Now, placing this in the coordinate plane is a little bit tougher. We're going to use the distance, midpoint, and slope formulas, okay? So think about where you're going to use these, okay? The distance formula is anytime you're going to have sides congruent. Right? You're going to use the distance formula to show that opposite sides are congruent. Opposite. Okay? You'll use the slope formula to show me that opposite sides are parallel. And you're going to use the midpoint formula. We haven't done it yet, but you will use it here to show me that the diagonals bisect each other. Okay, because if they intersect each other at the midpoint, then you're in good shape. So that's what we're going to do here. Alright, you can look through their examples. They do the distance and the slope formula for you, which is really nice. Alright, I'll do a couple examples for you as well. So I'm not going to actually graph these out because I know what the shapes kind of look like already. I can visualize it, but if you'd like to, it's definitely easiest to have it graphed out, and then that way you can just count for the slope and for the distance and all that kind of stuff. It makes it easier for you. Because you might not be able to do the distance, midpoint, and slope in your head. If you need extra help with that, I can give you extra practice, so just let me know. Okay, so the first one. You know that these are going to go in order, right? All these letters, right? These are always going to be consecutive sides. So in order to find the slope of all the sides, all you're going to do is find the slope of the two that are next to each other. So slope of AB, and then BC, and then CD, and then finally DA. Right? So if we're going to find those, it tells us to use the slope formula. The slope of AB. All right, remember it's y2 minus y1 over x2 minus x1. So it's going to be 3 minus 0 over 1 minus 0, which reduces to 3. Okay, the slope of BC. All right, remember this one shouldn't be the same as the one I just got because these are consecutive sides. One's right next to each other. But so you do 3 minus 3 is 0, and 5 minus 1 is 4. So 0 over 4 reduces to 0. All right, then we'll find the slope of CD. You could do 0 minus 3 is negative 3, 4 minus 5 is negative 1, negative 3 over negative 1 is positive 3. That's good for us so far. And lastly, DA, right? 0 minus 0 is 0, 4 minus 0 is 0, so it's going to be 0 again. Okay, so now I know that the opposite sides are parallel. So since the opposite sides are parallel, right, all you have to tell me is opposite sides parallel. And that's why you can use the parallel symbol like that, or you can write it out. And that's the reason why this is for sure a parallelogram. Okay? All right, let's do one with the distance formula right below it. It says distance formula. You need to find the distance between all of these. Okay? Now remember for the distance, all right, what you do for each of these is you count the distance between each of these, the x value and the y value. Right, you square both of them, you add it up, and you take the square root of the result, basically doing the Pythagorean theorem. Okay. So the distance between negative 1 and 3 for our, not AB, RS. That sucks. RS. Okay, so the distance between negative 1 and 3 is 4. 0, 0 is just 0, so it's 4 squared. is 16, and square root of 16 is 4. So that distance is 4. Really easy because it's pretty linear. Okay, the distance of ST, okay, from 3 to 2 it's 1, and from 0 to negative 3 it's 3. So 1 squared plus 3 squared is square root of 10. All right, if you could reduce that, I would definitely want you to, but we can't there. So you just leave it. For TU, we've got distance from 2 to negative 3. It's going to put us at 5. And from negative 3 to negative 2, it's going to put us at 1. So square root of 26. Let's see, from R to U, we've got the distance from negative 1 to negative 3 is 2. The distance from 0 to negative 2 is 2 again, so you're going to have square root of 8, which reduces to 2 root 2. Okay, so those are your 4 distances. Once you get those 4, you obviously check to see if opposite sides are congruent. Clearly not, right? All of them are different, so this is definitely not a parallelogram. Okay. Now, for the distance and slope formulas, if you're ever given something like that, what you're going to want to do is you're going to want to just find, you're going to use that case where you're just going to find one set of opposite sides, both parallel and congruent. Okay, so find the distance of opposite sides as well as the slope. So, for this one, I'm just going to do S and T and U and V, okay, as my 2 opposite sides. So, I'm going to find both the slope and the distance of ST. Slope of ST is going to be 4 plus 1 is 5. Negative 2 plus 1 is negative 1, so it's going to be negative 5. Right, the distance from S to T. Okay, we're going to have the distance from negative 2 to negative 1 is 1. 4 to negative 1 is 5, so it's going to be root 26. Right, for UV, right, we know that's an opposite side because they don't share any of the points, so there's no way they would touch each other. Okay, so from U to V, right, that slope is going to be 1 plus 5 and 2 minus 3, again negative 5. That's good so far. The distance from U to V, okay, distance from 3 to 2 is 1, and negative 4 to positive 1 is 5, so again root 26. When you add those up, 1 plus 25 is 26, can't reduce it. So you're good, right? So this is for sure congruent. The reason for it is because one set of opposite sides is both congruent and parallel. Okay. Lastly, the number 6, the midpoint. All right, let me show you an example of the midpoint. So for this one, we're going to actually work with the diagonals. Okay, so we're going to find the midpoint between 2 sides that are away from each other. Okay, because we know that those are across from each other. They're not actually touching. Right? We're going to find the midpoint of FH and then the midpoint of GI. They should come out to the exact same thing. If so, then you can prove that the diagonals bisect each other, and therefore, this is a parallelogram. Okay, so the midpoint of FH equals. So remember, the midpoint, you find the average of the x's and then the average of the y's. Okay, so 3 plus 3 minus 3, you add up the x's, divide by 2. That's 0 divided by 2 is 0. And the y, you add these up, you get 4 divided by 2 is 2. Right? Or halfway between 3 and 1 is going to be 2. Right? And the midpoint of GI, got 1 minus 1 is 0. 0 over 2 is 0. 2 plus 4 is 6. 6 divided by 2 is 3. These do not come out the same, right? One's at 0, 2, one's at 0, 3. So because that's the case, it's not a parallelogram. Okay, that's it.